So good morning everyone. The last class we discussed about fair list of subject headings and the Library of Congress subject headings. In continuing with that, today we are going to discuss about medical subject headings. That is MESH, MESH. The acronym stands MESH. Fine. So what is it actually? What do you mean by medical subject headings? So I have already told you it is a controlled vocabulary thesaurus developed by the National Library of Medicine for the purpose of indexing biomedical literature. Fine. So I have already told you what is controlled vocabulary, right? So that means you are controlling the vocabulary for a specific purpose. That means you are assigning a tag to a particular vocabulary. That is called as controlled vocabulary. So it is used by Medline PubMed article database and by NLM's catalog of books. Fine. So it appears in three volumes actually. So first is annotated alphabetical list. The second one is tree structures, medical subject headings in tree structures. That is, what do you mean by tree structure? There will be a root, and from the root there are different branches that evolve. That means there will be a connection, there will be a relation between the branches, there will be an association between the branches. So based on certain groupings, the structure will evolve. Similarly, the medical subject headings will have a relationship among them in the form of a branches, which is overall constitute to the structure of tree, right? And permuted medical subject headings. So we will see what these three are in detail. Fine. The annotated list. What do you mean by annotation? In the normal context, what we say annotation is when you share an image or something, you will write a tag or a little bit information about it. You will add a note about it. That additional information we call it as annotation. So for example, if you are sharing a picture of pizza in Facebook, you are adding a name. This picture is actually meant to this particular person, not to generalize it. That means you are giving a note, a specific information about what the picture is meaning. So similarly, this mesh annotated list contains main headings and topical, that is a topic or phrase, right? And form headings. We have discussed about what is form, right? Intellectual and physical form of the document, right? With certain notes and cross references in order to give more detail about the heading, right? And tree structures, I have already told you, it will have a root and a branch like structure. It consists of a categorical arrangement placing heading in relationship to other headings that represent similar areas and concept, right? So there will be one heading and another heading which are associated based on certain relationships. For example, let us take man as one heading, women as one heading, the certain human being or the common heading for that. You can associate it, you can relate it based on similarities between them. Fine. So third is permuted medical subject headings. It is a keyword index listing where each significant word in the subject heading, phrase or cross reference regardless of its position in the phrase. Okay, it is a keyword index. It is a keyword index where it lists each keywords, where it lists each important keywords in the subject heading regardless of its position. So this is permuted subject headings. So these are the three volumes of mesh medical subject headings. Fine. So now we are going to discuss the indexing process. Okay, indexing process and what the work done by the indexers, what the work done by the mesh medical subject heading indexers. Okay, so modern biomedical literature is extremely complex. So mesh indexers must have a broader background in life sciences to understand and analyze biomedical articles. That is true now. So as a role of an indexer, you must understand the thought content of the subject. That means you must have sufficient knowledge about the subject. Then only you can identify key terms or descriptors that actually represent the document. Okay. So this is medical subject heading we are dealing with. So what happens is it deals with biomedical literature, right? So when dealing with biomedical literature, as an indexer, you must have sufficient background on biomedical literature. Then only you will be able to assign key concepts or key terms that actually represent the thought content. So mostly mesh indexers have advanced degree in various biomedical sciences, right? It has they index more than 8,50,000 articles each year. for inclusion into PubMed Medline databases, which is the largest bibliographic database in the world. True. So they cover a broad spectrum of literature in the following disciplines, varying from medicine, nursing, dentistry, veterinary sciences, healthcare systems, life sciences, and some physical science subjects also, right? So the majority of the journals are indexed cover to cover. That is, what do you mean by cover to cover? That is, all the articles, substantive editorials, and even the letters are all indexed. Okay. Some journals are selectively indexed, meaning that only the article related to particular discipline or particular discipline like life sciences receive mesh headings. Okay. So they contain bibliographical citations and abstracts from more than 5,600 medical and life science journals, which are published in the United States and 70 other countries. So the database contains over 21 million citations. See the exhaustive coverage of this particular database, right? So that is why it is termed as the largest bibliographic database in the world. So the subject indexing principle includes three important criteria, that is three important parts. So what are they? First, you have to review a journal. So reviewing a journal, first step is reviewing a journal or other material such as letter or editorial, whatever it may be, and then after reviewing it, you have to determine, as the indexer should determine the subject content of what the journal or the article is, or the article is talking about, right? And the third part is describing the content using a controlled vocabulary. Okay, so you have to describe the content by using a structured controlled vocabulary. Here we are going to use medical subject headings, that is MESH. Fine. So first what the indexer does is reviewing the article thoroughly, and then he is determining the subject content. Yeah, this article is talking about talking about diseases related to heart or something like that. And then after determining the subject content, he is using the appropriate term to represent the subject content with the help of a controlled vocabulary. That is, in the sense, with the help of medical subject headings. They are a predefined set of keywords or headings that have certain descriptors according to its usage, right? So we will see that in the forthcoming slides. So this is the indexing process. This is the steps that is followed by the indexer. Okay. So first what he does is he reads carefully and understands the title. First you have to read and understand the title carefully, right? So I have mentioned this earlier, not all the concepts will be effectively represented with the title alone. Sometimes title will be a clear indicator. In certain cases, title will not be a clear indicator of the thought content of the subject. Okay, second, what you have to do, you have to scan the abstract to get an idea, to get an overview of what the article is talking about, right? And then you scan the introduction to locate the author's statement of purpose. So read and understand the statement of purpose. It provides more exhaustive information and more in-depth knowledge of what the article or what the subject is actually talking about. Title will just give you a mere idea, whereas the statement of purpose will give you a clear idea and the specific details about what the article is actually talking about. And do not index the background material. And check the methods and material section. So sometimes it describes the techniques or the data collection procedures, the subjects involved in case of clinical literature, the treatments involved, everything it will. So identify the methods and methodological section, identify key terms. Do not index routine methods described only in the materials and methods. They may also contain publication type of information as well as some important indexing concepts like ages, sexes, organisms, right? Focus on results section. Then you focus on the results section. Select for indexing only those subjects actually discussed, as opposed to subjects those are merely mentioned, right? So select subjects which are actually discussed. Some subjects they mention superficially, they don't discuss in detail. So select subjects, select the concepts based on the subjects that are discussed in detail. Okay. To identify the indexable content, indexer need to check section headings, paragraph headings, items such as tables, charts, diagrams, and other illustrations. So if you go through these things, you will get a clear idea about the broader context of what the subject is talking about, right? And then scan the summary or conclusion to identify the main points of the article. So main points is some of the key headings. So do not index implications or future applications. So recommendations for future research and other implications should not be used for indexing purposes. Note, the keywords supplied by the author or publisher for additional terms can also be considered for indexing. In certain cases, author will below the abstract, the author will provide certain list of keywords, right? So that might effectively represent the thought content of the document what the author is trying to convey in his research. Fine. So these are the general guidelines, these are the general steps the indexer follows to identify the indexing terms with the help of MESH. Okay, fine. So what is the role? When do you ascertain is a good indexer? What are the qualities a good indexer should have? Do not let bias or knowledge of a subject alter how the article is indexed. So your prior knowledge or your knowledge on the subject should not take influence, or you should not supersede to make decision on the indexing terms. Actually, that's what it's conveying. Just you merely represent what the article is talking about, even though even though if the article has some mistakes and it is not correct, means do not make any decisions. Just merely represent what the article is talking about. Just identify the key terms based on the content of the article. Okay, do not try to alter or change, or do not try to authorize the article, get an authority of the article. Do not try to do that. And always don't read word by word. It will take time, and that is not a good method of indexing. We are just going to identify the key concept. For that, you need not to read every word of the article. That is not necessary. So there will be stop words and there will be irrelevant words which we can, by superficial nature, we can omit it. Okay, just identify the key terms. Okay, always index using the most specific terms. Don't go by general terms. For example, cancer, if the article is talking about skin cancer, go by the specific term skin cancer. Don't use general cancer term, right? Be more specific as possible. So describe the concepts in article using mesh terms, that is medical subject heading. So mesh is having a predefined list of controlled vocabulary, that is predefined list of subject heading terms. So try to include those terms which will actually represent the context. Okay, fine. So next is first what you do is you are determining the thought content of the subject. Now you have to find terms. Now you are identifying what subject it is talking about. Now you have to identify the best terms that represent the subject, right? So they are normally what this indexer in medical subject headings they do is they refer the mesh browser. It has a good comprehensive list of vocabularies, right? So when the article falls in the category of the vocabulary which is indexed, actually you can ready-madely you can use it. Okay, so indexer use the most specific terms available to describe a concept. So specificity is more important here in order to represent a concept. So example, you see this, the liver disease chronic hepatitis B is indexed as the specific term hepatitis B chronic, right? They are not using liver disease, which will be a general term, generic term. So it is advisable to be more specific, right? So indexer use more than one heading if a single heading does not cover the concept. So this falls under the principle of coordination, and we will see what is coordination in the forthcoming slides. If there is more than one heading, that means if the indexer feels only one heading sufficiently alone does not represent the whole document, right? So there might be what is interdisciplinary, or there might be a combination of more than one concepts in a title or in a subject, right? In that case, only one heading will not effectively represent. So he has to combine more than one heading. So that falls under the category of coordination. For example, you see the below example. Yes, Mucinous adenocarcinoma of the ovary is indexed as C. They have added one heading along with the ovarian neoplasms, right? So that means they have added two important headings, which the indexer feels that they both effectively equally represent the content of the document. And in another case, if the exact heading does not exist, okay, indexers use the mesh browser and the hierarchy to find out the most specific heading available. In certain cases, you will not find the exact heading in the mesh vocabulary, right? In that case, you might find the most specific heading available related to it, right? Cardinal radiation therapy, that is the title. So you are not having the exact heading like cardinal radiation. So what is the related specific heading to that? Cardinal irradiation, which is under the radiotherapy branch of mesh tree, right? So you can use it. In case if it is not directly available, you can use the near most specific heading. Okay, fine. This is how you find terms to describe the thought content of the document. Okay, once you have found the terms, the next thing you have to identify is you have to give weightage to the terms, which is important and which is more important and which is least important, right? So that is what we are going to discuss in this particular slide, that is IM and NIM terms. Okay. So first what we did is we identify the determining the subject. So determining the subject of the journal article or whatever it may be. So we have determined this article is talking about life sciences or something like that. And then we are identifying the key terms. We are identifying the key terms which represents this particular subject, right? So which acts as an index. That key terms are going to act as an index. So after identifying the key terms, now what we are going to do, we are going to rank the key terms. That means we are going to give weightage. So this is very important key term. This is a sub key term. This is minor. It has a minor role. This has a major role. So according to the weightage given in the article, we are going to rank them accordingly. So that is why it is classified as IM and NIM. So as an indexer with sufficient background knowledge, that you should be able to rank it accordingly. It represents more percent of the more thought content of the document. It represents least content, some part of the documents, right? For example, an article describing kinetics of lactate dehydrogenase will be indexed with both lactate dehydrogenase and kinetics. Yes, it talks about both, right? It talks about kinetics as well as lactate dehydrogenase, right? But here you have to identify and weight. We have selected the key terms. Both the terms we have selected, but what we have to do, we have to assign them which is important and which is major and which is minor, right? So here you see that the main point is lactate dehydrogenase, while kinetic is simply a minor point which further specifies what is happening with lactase dehydrogenase, right? So once we identify and once we assign the weightage, we classify it as IM and NIM. IM is nothing but the main point and NIM is nothing but the minor point, right? So IM in the sense it is not important points or not important points. It is not like that. So it is the history derives based on Index Medicus, the publication of Index Medicus. In earlier, certain terms were published in Index Medicus. So the keywords which are printed in Index Medicus are termed as IM, and which are not printed in Index Medicus are termed as NIM. Okay. So in normal words, IM are the main points represent the main points of the article. NIM represent the minor points of the article. So IM concepts are always designated by asterisk symbol. Remember that. Okay, asterisk symbol that is given in the last part of the slide. Fine. So these are the common IM terms. They necessarily need not to be IM. These are the common IM terms, right? Organs, disease, organisms, and these are the common. However, if any of the above are not the focus of the article, they would be indexed as NIM. Remember that. Depending upon the article, what the content is talking about, it depends upon the importance of the concept of the article in hand. Based on that only, we have to select which is a major term and which is a minor term. That is IM and NIM. Okay, fine. So this is just a general. This is general, most frequently used. That doesn't necessarily constitute this will be the final. Based on the article in hand, we have to analyze it and we have to identify the IM and NIM terms. For example, terms like geographical locations, New York City, Africa cannot be made IM. These are the general rules you have to follow. Most articles require no more than 5 IM. So the minimum is it should be less than 5 or 5, right? So they can use, if the article demands, if the indexer thinks that more than 5 IM is necessary to represent the content, you can use it. If it demands, you can use it, or else no need to use more than 5, and it should not include geographical location or geographical terms. Okay, depending upon the article in hand, we have to categorize, distinguish which is IM and NIM. So these are the common NIM. It represents techniques, methods, experimental studies of animals, etc. So again, the same condition applies. It can be changed into vice versa also. Sometimes the frequently used NIM can be IM if it is the main point of the article. So always remember that the selection of a term as IM or NIM depends upon the importance of the concept in the article. So take the article in hand and identify the terms that represent the thought content, and then give weightage on depending upon the main point and major point and minor point, right? Then you distinguish it. Fine. So it is important to understand that terms which are usually used as NIM can sometimes be indexed as IM concept. That's what I am telling. So it is not a fixed rule based on the article in hand. In majority of the article, it might fall under NIM. In the article at your hand, this might be the main point. So you have to use it as IM only. For an example, the article about chronic gastrics will be indexed with the terms gastrics as an IM and chronic disease as an IM. That's true actually. Okay, gastrics is the important point here. Chronic disease is the minor point. However, an article about chronic disease in general will be indexed with the term chronic disease as a concept. That will be an IM, right? So see the specificity and see the concept, the point which the keyword is representing. Based on that, you assign the parameter whether it should be IM or NIM. The same rationale applies to concepts usually indexed as IM. In circumstances they will be indexed as IM. So I have told you it's vice versa, right? So IM concepts sometimes can be indexed as NIM, and NIM concepts sometimes can be indexed as IM depending upon the article in hand, what the article is talking about. That is very much important, right? So many articles can be adequately indexed with 15 or fewer. So we have seen that there is no more than 5 IMs here. Similarly, 15 or fewer NIM. It is important that indexers should use as many NIM as needed, but not add terms simply to reach a number. Yeah. So it is advisable to add many terms, but not for the sake of adding, for not the sake of increasing the number, right? It should definitely represent the sub part, that is the minor part. So you have to analyze it and identify the minor part, but you should not add it for the sake of increasing the number, right? That should be kept in mind. So not every concept mentioned in an article is an index. Concepts should be indexed only if they are discussed and not merely mentioned. That is the key rule. Okay, fine. So this is about IM and NIM concepts. Now we are going to see another parameter called check tags. And usually, what do you mean by checklist? So you have a certain criteria, and you are just finishing one by one, and you are checklisting it. That means I have completed step A, step B, like that. Similarly, here also certain tags that are having that certain words that are having check tags. So see, virtually in biomedical literature, all the biomedical article will describe subject of research. When you take a biomedical literature, they will test their medicine on certain subject. The subject may be human or animal or whatever it may be, right? They will test. Then only you can identify the improvement or the whether the health is improving or whether the health is deteriorating. So based on the subject only, in the subject in the sense not a discipline, that is a human subject or animal subject. So that will cover in every biomedical. In case of clinical research, what they will describe, they will identify the treatment. So for the fever, this is the best way to treat it. For depression, this is the best way to treat it. They will identify based on certain experiments. So clinical article will cover aspects like treatment, diagnosis, diseases in patients, whereas biomedical article will describe subjects like human subjects, animal subjects, so on, right? So these article will always mention these common data like number of patients tested, the gender proportions like this many males, this many females, and the age details also. And experiment articles will mention the species and gender of article, right? Human and animal are widely searched terms in PubMed. That is true, right? Medicine is related to improve the health, right? It is related directly with human health or animal health, right? So human and animal will be the core terms in biomedical literature. So these concepts are mentioned in almost every article. That's true. Human, animal, male, female, gender details, child or adult or whatever it may be are commonly designated as check tags. So these concepts are known as check tags. So in the past, what happened when what indexer MS medical subject heading indexer had to type the terms and data forms are printed and they will checklist it. They will just tick it with the frequently occurring concept. Okay, they are routinely added to the indexing. They are routinely added to the indexing even if it's just mentioned. Only the subject concept should be deeply analyzed, they should be discussed. But checklist, even if they are just mentioned, you have to include it. That is the criteria for checklist. So the check tag concept does not need to be discussed. That is the key. Whereas in the subject, whereas the subject concept, they need to be discussed. They should not be merely they should be discussed. They should not be merely presented in the article, right? Mentioned in the article. If an article only mentioned the subject, the study was a pregnant 35-year-old. Pregnant 35-year-old. What we know here, pregnant is definitely female. Pregnant is definitely female. The indexer must check if it is indexer must check the tags automatically. You must check the tags pregnancy, so human, female, and adult. If age is included, definitely it is talking about humans. For animals, you should not consider the age actually. So pregnancy it might be for animals also, for humans also. So age is included here. So age means animals in dealing with animals, age is not included, right, for indexing. So if the title has a pregnant 35-year-old, it is automatically talking about humans. So pregnancy, ultimately pregnancy is associated with the female, so human, female, and 35-year-olds is definitely adult, right? So these are the checklist categories that has to be indicated. These should be included in the indexing terms. Fine. So these are the common check tags: human, male, female, pregnancy. INF is infant, newborn baby to 1 month, till to 1 month, 0 to 1 month, and infant from 1 to 23 months, right? That is nearly less than 2 years. And child, pre-child, right? Preschool child or something, 2 to 5 years. And child 6 to, and adolescent age 13 to 18, young adult, mid-age, aged, 80 plus aged. These animals, rats, and these are the common checklist. Okay, these should be automatically should be included. Not as an IM, it should be as a check tag. Okay, fine. Checklist or not, IM, remember that. That is not the main concept. Fine. So pregnancy, dealing with pregnancy, all articles mentioning a pregnancy must have the check tag pregnancy. That is true. Then pregnancy is automatically a check tag, right? So when an article mentions about pregnancy, it should definitely have a check tag pregnancy. The indexer must check the tag. Then the indexer must ascertain whether the pregnancy is talking about human or animal. Pregnancy is associated with female, we know that. But whether we have to ascertain whether it's talking about human pregnancy or animal pregnancy, right? So if you ascertain that, then you have to add the tag, you have to add the checklist accordingly. If it is human means, so pregnancy human female, animals means pregnancy animal female, like that. Okay, fine. So pregnancy as a IM versus check tag. So if you see, I told you check tag cannot be, most probably check tags are not used as IM. But in certain cases it will happen if it is the main concept. If it is representing the main concept. See this particular example, pregnancy in developing countries. Here the core concept is pregnancy only. Here the core concept is it is talking about pregnancy in developing countries. Here the subject, here the article is talking about the pregnancy in developed countries. So definitely we are going to represent pregnancy as IM. I told you IM is represented by asterisk symbol. So here asterisk symbol and developing countries is another IM. That is another important concept. Okay. Another important concept. So what is the check tags here? If pregnancy is there, automatic check tag, it should be female, right? Female is automatic check tag, and human, it is talking about human. Okay, after analysis, we assume that it's talking about humans, and we are adding human and female as a check tag for the IM pregnancy. Fine. Similarly, you see this preeclampsia in Hispanic Americans. See this particular title here. What you say here, the this is not here what you say, you don't see explicit, you don't see the word pregnancy in explicit nature. But what do you mean by preeclampsia? Preeclampsia is a condition where the blood pressure increases for pregnant woman. When there is a increase in blood pressure, it has certain changes, it makes certain changes. It happens only for pregnant women. Okay, when the blood pressure increases and it makes some changes, they term it as preeclampsia. So it is associated with pregnancy only. So that is why the knowledge regarding biomedical and clinical literature is very much important to become a mesh indexer. Remember that. So what happens is, here pregnancy is not the IM, it will be the check tag. See, so it is talking about pregnancy, and here Pre-eclampsia will be the IM. That is the main concept, and Hispanic Americans is also the main concept. And I will tell you what is this. Ethanol actually? It is an indexed abbreviation, and I will tell you in detail about what is indexed abbreviation when we discuss about subdivisions or qualifiers, right? When I come to that part, I'll clearly explain what this is. Now at this slide you need to understand that here pregnancy is used as a check tag, not as an IM. In the first case, pregnancy is the important point, that is the main point, so it is used as a IM, and human and female are the check tag. Here pre-eclampsia and Hispanic Americans are the IMs, whereas pregnancy, human, female becomes the check tag. I hope you understand this particular concept. So next is we are going to deal with age. So the age group for check tags refer only to humans. That's what I told you in the previous slides, right? Do not use age group for the check tag animals. Here in this example, they have given clearly the age is 35-year-old. So what is the protocol saying? Do not use age group for animals. Here they have age mentioned. Automatically you can assume that it is for humans. Simple. Fine. Okay. So indexer must check the tag human if any of the age tags are checked. Okay. If age tag is checked means you have to automatically check it. You have to automatically include the check tag human, right? So for animals we don't include age tags, right? So indexers must check appropriate age group check tags even if the age group appears obvious. Okay, you must check the appropriate age groups. For example, if child behavior is indexed, if child behavior is indexed, check the tag child or specific such as child, preschool and human must be checked. Okay. So here child behavior is indexed, right? So they are talking about child behavior. So you have to the check tag child or the check tag child should definitely be indexed, and or depending upon the content which kind of child it is referring. So you have to be specific whether it's child or preschool child or adolescent or something like that, or no, it is not adolescent, it is talking about child, and human should be there. Human is a common factor, right? Human should be there whether it's adult or child or adolescent or whatever, infant or everything is human, falls under the common category of human. So human should be a check tag, and depending upon the nature of the subject, it is nature of the subject the article representing, you have to check tag, you have to add the check tags accordingly. So indexers must check all appropriate age group check tags if a range of ages appear in the article. If there is no specific or fixed range, and if the range is varies, and if the ages varies, no, there is no specific fixed age or fixed defined age for a population. If the range varies from 15 years to 20 years like that, you have to check all the appropriate check tags. You have to include all the appropriate check tags for index. For example, an article with subjects ranging in the age 7 to 17, and you see it includes all kinds of human beings, right? It includes child, preschool child, adult, young adult, and aged adult. Everything it is there. Every kind of every kind of human growth is there, right? So in that case you have to include all the check tags like human, that is a common check tag. Then you include child, adolescent, young adult, mid-age and aged. Everything should be included. Appropriate age should be included. So this is the common criteria you should follow. If the article states infant, generally infant means use infant 1 to 23 months. Don't use new. Don't include new ampersand and all. Use specific. Be specific. Include one. If the article says child only, not specifying what kind of child, use child 6 to 12. Don't use pre-child and all. Okay. If the article state adult, use general adult 19 to 44. Don't use mid-age and old age and all. Fine. So next is animal. If any article discussing about animal must have a check tag, definitely animal. So examination and health of diabetics in tiger or lion, whatever it may be, any animal. If any article is discussing about animal, automatically you have to include the index term in the check tag animal, right? So index also the specific animals, let it be if it is talking about rats, mice, use the check tag if available, or the main heading or main heading. In case of what you say, adult, young, or a child, everything falls under the main heading human. Here this rat, mice, lion, tiger, cat, whatever it may be, everything falls under the everything falls under the main class animal. So main class should be there and the specific class should be there. Specific check tag should be there. So if an article describes the use of tissue from an animal, a part or a tissue from an animal, index the tag animal and the name of the animal or a main heading, right? Use the tag animal even if the IM term is what do you say, animal specific, like hoof or udder. Okay, hoof is the bottom part of the horses or some these things, right? So these are parts. Even though you have to include this check tag animal and the specific animal, right? And the animal specific, right? So these are the common criteria. If an animal is a veterinary entity, then use the animal as an IM heading, that is a main heading. For example, humoral immunity in sheep. So that is what they are talking, humoral immunity in sheep. So what you have to do is, here sheep is a veterinary entity, sheep is an animal. So in this case, you have to use sheep as a IM, that is a main point, and animal as a check tag. Animal is definitely a check tag, and here sheep becomes a IM. So in the second case, an experimental subject for which there is a check tag. An experimental subject, if animal is an experimental subject for which there is a check tag, remember that animal becomes an experimental subject. That means, and also it is having a check tag. So what you have to do is, as an indexer, check tag animal and specific animal check tag. So animal here becomes a check tag, and the specific animals which is being experimented also becomes a check tag. So for example, response of cultured hamster cells to X-ray. Here hamster is an animal, right? So here what they are doing, they are experimenting hamsters, the cells of the hamsters, to the exposure of X-rays. They are experimenting something. They are experimenting the animal. They are experimenting. So here the animal becomes an experimental subject. Okay. The cells of hamster becomes an experimental subject, animal becomes an experimental subject where there is a check tag, right? So what happens is, automatically animal becomes a check tag, and the hamster, the specific animals, also becomes a check tag. So animal is the main check tag and hamster is a specific check tag, general and specific check tag. So in the case of third criteria, if the animal is an experimental subject, like previously mentioned, for which there is no check tag, then what you have to do, you have to check tag the animal. You have to check tag animal should be the general heading, animal should be in the check tag, and specific animal, or in what animal they are talking about, that should be as the main heading. Not IM heading, as a main heading, NIM. So action potential of Anura neuromuscular junction. Action potential of Anura neuromuscular junction. Here you see there is an experimental subject, but there is no check tag. How? So the experimental subject is Anura. But there is no specific specific check tag. What do you mean by that? Anura is nothing but it tells about tailless amphibians. In generally, what do we designate as amphibians? Uh, a living being which can survive on land as well as in water. That is called amphibian, right? So Anura is specifically telling that tailless amphibian. So what kind of animals are tailless amphibians? We can take frog as an example, right? And toads as an example. So these are tailless, and amphibian which has no tail are termed as Anura. So here there is no checklist, right? When the previous there is hamster specific, here there is no check tag. So what you have to do is, Anura becomes a NIM. That is the minor heading, right? Where animal is the main heading, right? Anura becomes a minor heading. And regarding Anura, they are testing frogs or toads or whatever other representative of Anura that we have to analyze, right? So that becomes so here animal becomes a check tag and Anura becomes a NIM, right? So this is the difference between point 2 and point 3. And in case of point 4, if the animal is the main point of the article, that if animal is IM of the article, such as species in anatomy studies, then the index as an indexer, what you should do, you should be using the animal as an IM. They have clearly mentioned animal as a main point. Then it's automatically it becomes IM, and IM and the animal definitely becomes a check tag. Yeah, general class is animal, general tag is animal, and animal, in which specific animal they are talking about, that is anatomy of cat joints. In the case of species and anatomy, that's what they are referring, anatomy of cat joints. So here cat is the animal they are talking about, so automatically cat becomes the IM and animal becomes a check tag because cat is a animal. So 1 and 4 follow the same rule, where 2 and 3 you have to ascertain whether it is an experimental subject, whether the animal is an experimental subject with the check tag or without the check tag. Depending upon that, you have to use the indexing terminologies accordingly. Fine. For all these 4 different kind of examples, you see one common animal. The general class will always be there in the check tag, and depending upon where the animal is used, the specific animal will vary, right? That is what similarly for humans, the general class human will always be in the check tag. Okay, depending upon which kind of human they are referring, whether female or male, it varies. Fine, the headings varies. So now we are going to discuss about human, male, female, and chronological tags, right? So human, we all know that, used for any article that involves a human being, a pregnant woman, okay, a veteran, old male, or something like that. A male and female, used for both animal. Male and female represents both humans as well as animals. Remember that it is a living being. It is equal for both male and animal. For humans as well as animals. So you use the check tags denoting sex even when the concept is inherently male or female. Okay. So what happens is we have to use the check tag denoting sex even when the concept is male or female. For example, the articles with the term prostate must have a check tag male. That's true actually. It is a gland. Prostate is a gland which is a part of male, right? So automatically you have to use male. Fine. Now we are going to discuss the chronological tags. So it is used in conjunction with the publication types, like historical article, biography, autobiography, in a chronological order, right? If the material covers a time period such as 15th century to the 20th century, check each time period tag covered, right? So see, for ancient the tag is C, for medieval the tag is D, for 15th century F, similarly till 21st century it is O. So if a material covers from 15 to 20Y, you have to include each check tag, each chronological tag, like F, G, H, I, J, like that. For example, if an article discusses from January 1, 2001, that means it is talking about 20th century. It is beginning with the 20th century. You can automatically add O. Fine. Now we are going to see what is mean by major topic. That important point. IM will be the major topic, right? Asterisks asterisks. I have told you IM will be represented in asterisks. That is the major topic. On medical subject headings and subheadings, designate they are the major topics of the articles. Let it be a heading or let it be a subject headings, they will be the major topics of the article. They are usually obtained from the title and the statement of the purpose. So non-major, what do you mean by non-major topics? They are non-asterisked. You can identify based on the asterisk symbol adjacent to the topic, right? So in the case of example, wound healing, radiation effects, that means these are major topics. Fine. So non-asterisks or non-major means the keyword does not have an asterisk symbol. Okay, they have done enough to qualify as index terms, but they are not major. Okay, so they are added like check tags. They are qualified as index terms, but they are definitely non-major. Uh, the only indexed midline citation without an asterisk headings are biographies with the subject name only be considered as the only major point, right? Biographies where the subject name will be the only major point, right? Supplementary concepts headings cannot be asterisk or carry subheadings. Supplementary concepts should not carry any subheadings and it should not be a major point. However, they are mapped to a mesh heading that is automatically added to the citation. They are mapped to the corresponding mesh headings, right? Fine. So coordination, I have told you about coordination. In certain cases, what happens is only one keyword does not effectively represent the thought content of the subject. You have to use two different headings to represent the exact content of the subject. In that case, you have to fall in accordance with the principle of coordinations. It cannot be adequately described with a single mesh terms, right? So it is a combination of appropriate mesh headings, subheadings, and check tags to index a concept as specifically as possible. In order to be more specific, we are using more than one IMs or one headings, right? It can be accomplished by using a subheading to describe a specific aspect of mesh heading, or using two mesh headings, coordinating subheadings on two or more headings, coordinating a major, that is a asterisk heading, with a non-major heading, right? Coordinating a heading with one or more check tags, indexing a pre-coordinated mesh headings which combines two concepts at once. That means you are combining something, let it be a major term or a non-major term, let it be one major term or with two or more check tags or whatever it may be. You are coordinating, you are combining something in order to be more specific to represent the thought content of the document, and we will see this coordinated with specific examples in the forthcoming slides. So depth of indexing and the rule of three. For most research article, every concept substantially discussed should be covered at least by one mesh heading. So whatever the article you are going to index, the indexer going to index, I told you mesh headings has predefined list of controlled vocabulary terms that can be effectively used to represent the document. So in most cases, you have to make sure that the article which you are going to index has at least one predefined mesh heading, at least one pre. In most of the cases, it will be there. In some cases, you will not have. In some cases, you will not have. You cannot find out words from mesh headings. In that case, you can use similar headings. Okay. Even negative findings are also discussed. That is a depth. You are going in detail about the article. Even the negative findings are also, if the negative findings are also indexed, if it is discussed, remember, not mentioned, if it is discussed, you have to include it. For articles discussing main subjects, general headings, but as specific as possible, maybe grouped related to concept rather indexing them individually. So one article might discuss more than one subject. For example, it will discuss about turtle, it will discuss about crocodiles, it will discuss about alligator. Everything will be discussed in a single article. If they are of the same group, you can term them as reptiles. You can generalize it using a single concept. If they are related to each other, if they are not related, means you have to be more specific. You have to separate them. Some items such as review, articles, letter, are index and non-depth. So for the above one, I said it should be in depth. That means you are going with the findings, everything. You are analyzing the document in detail. Some items such as review letters are non-depth. What do you mean by that? All major topics are indexed. All minor topics required for complete coordination of the major topics are indexed. So minor topics are required for complete coordination. What do you mean by coordination? Combining one or more terms to represent the content of the document specifically. So this is a example of mesh indexing for a specific article. This is an example. See, this is the article in hand. You are going to assign indexing terms for this particular article. So how will you do that? So article title is the role of coenzyme Q10 in heart failure. First you have to understand what is coenzyme Q10. Coenzyme Q10 is an antioxidant. So what it does is it is automatically produced in the human body in order to maintain stability for the growth and development. If it is less, means if the count is if the coenzyme is less, means you will face some health problems. So that is what they are assessing. What is the role of this coenzyme Q10 in heart failure? Okay, if coenzyme, what is the role it plays in heart failure? So if it is added, whether the heart is being able to work properly, work work in a stable condition. That's what they are assessing. They are evaluating in this particular research. Now, when you see the objective, to review the clinical data demonstrating the safety and efficacy of coenzyme Q10 in heart failure. To review the clinical, they are reviewing the clinical data which demonstrate the safety and efficacy of coenzyme in heart failure. So that they have collected data sources through Medline. The literature is collected through Medline using the search terms. These search terms should be indexed, right? These are the search terms: coenzyme, heart failures, antioxidants, and oxidative stress. These are the terms they have used. So automatically you should be indexing that. Fine. So here they have clearly mentioned human subjects. Heart failure. Generally, if you take heart failure from the title, you cannot ascertain whether they are talking about human heart failure or animals heart failure. Here they have clearly mentioned human subject. See, so that means humans becomes a subject here. Fine. And they have not mentioned what is a male and female. They are in a general concept human, right? So here you see coenzyme. Here you see coenzyme. Coenzyme becomes a keyword. It is also available in mesh. You can automatically take it. Here they have given the objective is to demonstrate the safety and efficacy. That means the data, based on the data, whether this antioxidant, this coenzyme as an antioxidant, whether it treats heart failure. That's what they are measuring. The real objective is that only. They are measuring whether it treats, whether it plays an active role in treating heart failure, whether it plays an active role in preventing heart failure. That means, so treatment becomes the major topic. Therapeutic use, that is treatment. Therapeutic is treatment. So that becomes a major topic here, not coenzymes, right? They are using coenzymes to treat heart failure. Remember that is the objective of that. So that here, so you have to analyze the context in which the document is representing. So that's why it is given in asterisk. And therapy. Okay, drug therapy. It is a drug. Coenzyme is a drug. It's kind of a drug. It will produce automatically. In case, what will you do if it is low in count? They will inject it as a drug. So it becomes a drug therapy. So it is also a IM. It is also a IM. So other heart failure pathology and physiopathology. Pathology is nothing but what do you say, the science of study, the study about effect and cure of diseases. Okay, so here heart failure is a disease, we can take it as a disease, and they are studying about it, effect and cure. So that with a broader term they will call it as pathology. And physiopathology, they are talking about the anatomical structure of anatomical part of an physiological part of pathology. That's why they have termed it as physiopathology. So these are the terms you have to add and index it, right? So oxidative stress. So what happens is oxidative stress means it creates if sufficient antioxidant is not available, what will happen? The oxidation stress will increase. As a result, there will be an imbalance and the reactions of the chemicals will change, which in turn causes deterioration of the body or deterioration of the health. That is oxidative stress, right? So you have to maintain your oxidative stress. If it increases, it is not good. For that only coenzyme Q10 serves as an antioxidant. It will maintain the balance between the chemicals. So if that is high chemical reaction means your body automatically it will affect your heart. That's what they are conveying here, right? Ubiquinone is nothing but another term for coenzyme 10. So automatically it is included. These are the substances, these are the mesh terms, and we have identified the IMs. This is how a mesh indexer index terms. They are taking terms from existing controlled vocabulary which is predefined, and according to the article, according to the content which it is talking about, they are adding terms about it. Fine. So this is an example of a mesh indexing for a specific article. Fine. So there are different record types. Medical subject heading has different record types. One is descriptors that characterize the main subject, that characterize the subject matter, what it is, main headings. And one other is qualifiers. I have told you about qualifiers. They are subheadings. They are grouping together the documents concerned with a particular subject. A list of subheadings that appear following the list of new descriptors. There are subheadings. Cancer, and the subheadings is cancer is the main heading. The subheadings is skin cancer. Here human is the main heading, and what you say, human male or female will be the subheading. Like that, they are the qualifiers. Entry terms are what we call it as related terms. They are closely related terms. They are cross-reference descriptors. They are cross-references. And we will see what cross-references medical subject heading has in the forthcoming slides. Okay. Generally, entry vocabulary may be used interchangeably with preferred descriptor for searching. For example, if you are using heart, you can use cross-reference cardio or something like that. So we can use it interchangeably. That is related terms, right? Fine. So complex concepts can be expressed in three different ways. In case of complex, in case if the concept is not simple, if the concept is complex, they are representing using three different ways. The first is coordination, that is combining more than one concept. You combine two or more separate descriptors. For example, jejunal entities may be enti- entities may be expressed by the use of jejunal disease plus enteritis. Okay. So they are combining diseases with the second concept. Secondly, qualifiers can be used in conjunction with appropriate descriptors, right? Qualifiers can be used in conjunction with appropriate descriptors, right? That's the principle of coordination. Fine. What happens is there will be a descriptor as a main heading and the qualifier will be a subheading. You have to use it with appropriate description. A deficiency of mon monoamine oxidase may be indexed as monoamine oxidase and deficiency, right? A deficiency will be the what is a deficiency will be the qualifier, that is a subheading. Monoamine oxidase will be the main heading. So that is how you can represent complex subjects. The direct linkage of the qualifier to the descriptor which it relates avoids a possibility of false coordination that it may occur if two descriptors are used to represent a single concept. The direct linkage will avoid false coordination, that means combining different coordination, different headings, combining different headings. But what happens is that sometimes they might not represent, though they are descriptor. If you are combining wrong descriptor, two different descriptors, it might not work effectively. That will result in false coordination. So there will be a descriptor and there is a linkage between subheadings. So that is the second item. The first one is linking two descriptors, that is two main headings properly. Second is there is a main heading and there is a linkage with subheading. And the third is pre-coordinated descriptors are contained in MES frequently for encountered subject, right? There are pre-coordinate indexing, we call it as. Okay, that chain indexing, precise something. These are the examples of pre-coordinate. If mesh has pre-coordinate descriptors such as heart surgery, the indexer cataloger uses it rather than a descriptor qualifier combination. That's correct actually. If mesh term is ready-madely available, it is pre-coordinated. So mesh subject heading is a predefined list of controlled vocabulary for medical terms, right? So if it is ready-madely available as a descriptor for heart surgery, you can automatically use it instead of a descriptor qualifier, right? Instead of using a descriptor qualifier combination or co-principle of coordination, whatever it may be, if it is ready-madely available. Okay. If descriptor qualifier combination is also available, then it will be used. Then it should be used. If it is not available, use the predefined, pre-coordinated terms. That is the base they are using to express complex concepts. So these are the mesh headings and the tree. I have already told you mesh is nothing but a predefined list of controlled vocabulary that are organized hierarchically according to certain order of rank, which is divided into 16 trees. So each tree is assigned a letter as an identifier. So the tree anatomy has identifier A, organisms B. So there are 16 trees in the hierarchical order. From that there will be subdivisions and something like this for each tree. So each mesh term is located in one or more trees. That is true actually. One term can be in more than one tree. For example, in anatomy also there will be a term called anatomy of anatomy or you can find a mesh term in anatomy also, and you can find a mesh term in diseases also. There is a possibility. That means a term will be available in more than one tree. That is what they are meaning here. The tree structure goes from general to specific, like human, male, female. That is general to specific. It is important that indexer uses the trees to find the most specific term applicable. So it is essential for the indexer to use the more specific term applicable rather than being general. So each mesh record contains a portion of tree showing its location. So below is an example of the tree location for mesh term peritoneum. Peritoneum is a membrane. It's a membrane that flows in the abdominal cavity. Okay, fine. So see for the mesh term peritoneum. See the tree relationship, tree the branches relationship, it falls in the body region and the subdivision torso, abdomen, abdominal cavity, then comes the peritoneum. So you have to be more specific. You should not use body region as an indexer. For the location peritoneum, be more specific. Fine. So you have to identify the appropriate heading, appropriate generic term to identify, to get into the specific term. So the mesh trees are very important to the indexing process and indexers should routinely use them. So indexers should always scroll down the tree in the mesh browser to see if a more specific term than the one they choose is available. So once you have ascertained certain term, once you have ascertained you have fixed a term, you have identified a term, and you have to check it with the existing mesh subject headings to see whether they are more specific than the term you have selected. If mesh term is more specific, you have to use that mesh term only. Indexers should use a tree to group mesh terms if the article discusses several concepts. Sometimes there will be sometimes the article will discuss several similar concepts. Similar concepts will be discussed in several ways. Diseases, drugs, techniques, they can be grouped under the next more general terms by the tree structure. So again, I told you, use rule of 3 below to determine which term to index. Rule of 3 acts as a guide to determine which is the best term for index, right? Indexers should view the tree where a specific mesh term is located to help determine the slant of the article and the choice of the subheading. Okay, for example, com complement activation is located under immune system processes. So that is the tree number here, G12 or G12. So G is, we know what is G, right? Phenomenon processes. So G is the main tree and 4.5 is the branch number or something. The slant of an article where complement activation is the main point would be immunologic. Okay, the subheading immunology will be used as an appropriate organ here, organism or disease where the term complement activation is taking place. So this is how you have to view the tree to identify the specific mesh term. Okay, in order to determine the slant of an article and the choice of subheadings. So complement activation in patients with rheumatoid arthritis. Here, complement activation automatically becomes the IM, right? Automatically becomes the IM. Located under, it is located under immune system process, that is G. Again, you are using immunol, arthritis and rheumatoid and immunol as the IM. It is the second one is qualifier descriptor. Right? The second one is qualifier descriptor. Second one is qualifier descriptor in the sense that is main heading, which is represented by asterisk. Qualifier in the sense that is subheading, right? So artist is rheumatoid or subheading. Okay, human is a check tag. So the second is in order to represent complex object, we are using qualifier descriptor. Artist is rheumatoid will be the subtopic, that is will be the qualifier, where immunol. Okay, because it is located because that is what it is talking about, right? So it will automatically become the it will automatically become the IM. So immunol they have given in what is a short, because that is called as index, indexed abbreviation. So we will see what is indexed abbreviation while discussing about qualifier. So automatically they are talking about when you analyze the article, they are talking about human subjects. So automatically human becomes a check tag. Fine. So this is how you analyze the complex subjects based on the help of the mesh here, a tree of hierarchical structure, right? So rule of 3, I have already told you, as an indexer, they try to select the most specific term that describes the concept of the article. However, if there are more than 3 specific terms treated under a more general concept common to all discussed in the article, then index a general concept IM and specific NIM, not all depending upon the article. So as I told you, if there are 3 or more terms, if the article is talking about turtles or alligators, crocodiles and others, you can index you can use IM you can use the main term as a general one. What is the general one for these three fall into the category of reptiles. So reptile will become the IM here, turtle, alligator or crocodile will become the NIM. Automatically. So not all, you should not use all unless it is essential and unless each are discussed in the article. Fine. For example, levels of the aspartic acid and and glutamic acid, and these things, polyglutamic acid and isoasparatic acid, can be indexed as amino because they fall into the same cluster, same group. So they here amino acid can be the IM and others can be the NIM. Similarly with the case of reptile example. So this is the mesh record for the peritoneum subject heading, mesh descriptor. This descriptor, in the sense, what do you mean by that is a main heading. So see, mesh heading is the peritoneum, and the tree number. Tree number, it falls in A, anatomy, and this is the tree number, and it is given a unique ID, the classification number by NLM. Annotation, I told you what is annotation. Adding a note, this is used for this purpose only, okay? Giving a specific information in the context where it is used. Do not confuse with peritoneal cavity. So do not confuse this with particular term. That is different. That's what they're conveying, right? And they're giving a scope note, a membrane. It is a membrane of, that's what I told you. It's a membrane of squamous uh, epithelial cells, right? They are giving a some detailed scope about where it is used exactly, right? The entry term is related terms. That's what I told you. See, cross references, that's a cross references entries that can be used here, related terms, right? And C also they are using it, okay? Where and date of entry, when this particular heading was added, and when any revisions regarding this data was made, everything is given here in the record. Allowable qualifiers. Qualifiers are allowable subheadings for this particular descriptor. That is qualifier. And annotations. This is the definition of annotation. The scope name is scientific definition. Scope note give you the scientific definition. It is annotations give you indexing informations. Whether it is IM or NIM designations or coordinations or subheadings to use for certain conditions, depending upon the conditions what the article is talking about, whether you can use it as an IM or NIM or something like that. A standard definition about this particular heading, you can find it in the scope note. An entry term, synonyms, related or alternate spellings of the main headings, which can be used for indexing. Some entry terms are not listed in the trees. Remember that entry terms are not in the trees. See also, it's a cross reference, provides a list of other related terms. Allowable qualifiers, it's subheadings. Qualifiers are subheadings. Descriptors are main headings. Descriptor qualifier means headings and main subheadings. Simple. Now we are going to discuss in detail about subheadings, that is qualifiers. So most articles are on very specific subject, and mesh headings are alone not sufficient to cover the specificity. Yeah, that's true. Only main heading cannot entirely represent the thought content of the document. Right? There should be some subheadings. Right? They are used to describe the specific absent. If you talk about cancer means it's a general heading, right? They are in the article they are talking about skin cancer. So how cancer can alone effectively represent? It will not. So you have to use some subheading, cancer as a descriptor and subheading, and skin cancer as a qualifier, that is subheading, in order to effectively represent the content of the article. The subheading that reflects the main point of the article is IM. Okay, that is reflect the main point of the article. When any heading, any subheading which reflects the main point, that will be IM automatically, while others will be NIM. Most MS terms, especially those categories from A, B, C, D, will be usually indexed in A, B, C, D. Okay, A, B, C, D. A is anatomy, B is organisms, I guess, and B, C, D, you should be indexed with one or more subheadings. Usually no more than 3 subheadings are needed, rule of 3 or something. However, index can use more than 3 if it demands. That is what rule general. If it is demands and if the indexer feels it is necessary to use it, you can use it, or else no need to use it. Fine. Myocardial infraction. Myocardial infraction. A main heading hyphen subheading is a combination, appears as a main heading followed by a forward slash and then the subheading. So indexers will index surgical treatment of myocardial infraction as. So surgical treatment of myocardial infraction is, myocardial infraction will be IM also, and surgical will be the myocardial infraction will be one of the keywords. Surgical treatment will be the keyword. So SURG is nothing but I have already told you that is indexed, that is indexed abbreviation. I will tell you what it is. So currently mesh has total 76 qualifiers, that is 76 subheadings. It appears in 3 forms. Remember, it appears in 3 forms: full name, 2-letter abbreviation, and indexed abbreviation. So that is what I was talking about. See this particular example, growth and development can be written in three forms. Growth and development without any change, full name, full spelling, okay. And GD, if they represent only two-letter abbreviation, GD, that is growth. And only growth, slash growth, only slash growth, that is indexing abbreviation. For the indexing purpose, they are using a predefined abbreviation. Fine. It is important to use the most specific subheading. It is very much specific compared to for the article. Some subheadings fall into natural groups which can be used to avoid unnecessary depth of indexing. Natural groups, if it falls under natural groups, you can avoid. For example, the general subheading therapy can be used to group the most specific subheadings like drug therapy, radiotherapy, surgery, diet therapy. Okay, if all these kind of therapy is discussed in a single article, you can group it into a common subheading called therapy. Fine. Indexer must not force a subheading. If subheading does not apply, don't use it. Only if it is discussed and only it is applicable to the article, then use it, or else do not force it for the sake of adding. Avoid using redundant unnecessary subheadings, especially with terms from category G. For example, subheadings genet with genes does not convey any additional information, and it is not necessary. That's true. So genes is already given. Then no point is using a subheading genet for that, right? It will not add any. It will not add any substantial value. Okay, to the existing descriptor. That's what they are mentioning here. Fine. This is about subheadings, and these are the 76 subheadings. So I have not given each and every 76 subheadings. This is how it will look like when you go to the website of PubMed or NLM. You will easily find this. Okay, so this is how it has looked like. These are the medical topical qualifiers listed by name, abbreviation, short form, and each qualifier is defined by a scope note. What is scope note? A guidance on how it is used, a scientific definition, right? Where it is used and how to use it. So abnormalities, that is the three forms. A subheading can be represented in three forms. That is in the full name. Abnormalities is the full name. AB is the two-lettered abbreviation, and abnorm is the indexed abbreviation. So one subheading can be represented in three forms, right? So when you see SURG, IMMOUL, that are indexed abbreviation, right? Fine. So similarly, these are the where it is used. Abnormalities are used with organs for congenital defects producing changes in the morphology of the organ. It can be used with this context. When you get a title based on this, when a title based on this particular concept, you have to use this heading. This is the guidebook. This is how you have to. The indexer makes use of this medical subject heading terms to index the content of the document properly. So how to properly use the subheadings. So ANAT is one subheading and CITAL is one subheading. You see what ANAT is talking about. The subheading, the full form is, the full name is anatomy and history. If you see here, anatomy history is the full name. AH will be the two-letter abbreviation, and ANAT, ANAT is the indexed abbreviation. Here the index abbreviation ANAT is given. It is used for where it is used with organs, regions, and tissues for normal descriptive anatomy and histology, and for the normal anatomy and structure of animals and plants. Okay, it's used in multicellular organisms. So ANAT is used for articles. ANAT is used for articles either on gross anatomy or tissue histology. So gross anatomy is nothing but visible anatomy, anatomical parts which are visible and apparent. Okay, gross anatomy, that's what they call it as gross anatomy. So it should be interpreted as anatomy or histology. Remember, the ampersand, the symbol ampersand does not mean the article must discuss both. Okay, in AND operator, what we say, it includes both. It should be interpreted as OR operator only. Ampersand is OR operator. It should not either or, either this or that, not both. Okay, remember that. So you see the title, anatomy of amygdaloid complex. So in this case, amygdaloid is a what do you say? It's a part in the brain. It's a part in the brain which which deals with which governs, which has a vital role in the human emotions and behavior. It plays a vital role in human emotions and behavior. So it falls under gross anatomy. So you can use the subheading ANAT as a IM. Okay, fine. Principles of coordination. I told you that I have told you the concept of coordination, principles of coordination. We will see this with a specific example. It is a combination. Right? It is a combination. By proper coordination, a limited number of mesh headings and appropriate subheadings index can describe the entire content in lengthy and complex article. Okay, now that means more than one heading is used to describe the thought content of the document. You are combining more than one heading. Simple as that. Okay, fine. Here are some of the examples of common coordination. If the article discusses treatment of a disease with a drug, so if the article discusses treatment of a disease with a drug, so treatment is discusses, a drug is discussed. Treatment of a disease. We can take corona as an example. Corona is a disease. Treatment is some injection is a vaccine. You are using some ethanol or some drug. Okay. Indexing would be disease. Okay, disease. Drug will be the what you said. Drug. THER, drug THER is therapeutic. That is the indexed abbreviation. Remember that. So that will be the main ending, right? That will be the IM. So you can use it, and you can represent drug. You can represent drug and therapeutic use. That is the indexed terms. Okay, these two will be automatically effectively represent the thought content of the subject. It will be wrong. It will be wrong if you use disease, drug, therapeutic, or drug, metabolism. It is not dealing with metabolism, right? So you have to identify where the vocabulary is controlled and where the vocabulary used. Based on that, we have to select the indexing terms appropriately. Done. So now we are going to deal about the cross references. I have told you about cross references, right? Entry list. So there are two categories of references. One is C references, another one is related concept. So C references are usually reciprocal entries. The entry is reciprocal in nature, and they are indicated by X. They are indicated by the symbol notation X. So chlorine, iodine. Okay, that is reciprocal in nature. Okay, fine, opposite in nature. So in case of related indicators, there are two types. There are further two types. They are C related and consider also. These are the two types. C related in the sense that they indicate the presence of other heading related to the concept, related to the topic conceptual. They relate one heading to other heading based on their conceptual relationship. So see, child daycare, if the title has child daycare centers, they are based on the conceptual relation. You can see related documents, the documents related to nurseries. So they are conceptually related. So that for that they are using C related, and C related is represented using the notation XR, whereas C is represented using X. Okay, remember that. And in case of consider also, it was instituted in 1991. They are primarily used with anatomic headings. I consider also reference. It refers to a group that has a beginning with a common word stem. For example, heart. You can consider for referring for materials in heart. You can also consider cardio or myocardial system, something like that. You are giving a consideration to based on certain common words, common terminologies, which are linguistically related. Okay, fine. So this is all about PubMed. Sorry, medical subject headings. Now we are going to see the practical aspects. So go to Google and type PubMed, and you will come to this particular home page. In the PubMed, when you scroll down, you will definitely find this mesh database, which is highlighted here. Just to access this database, just click it. It will take you to this particular page. In that particular page, it will give a brief definition of what mesh is about. I told you it is a predefined list of controlled vocabulary for indexing articles on Medline. So whatever articles which are available, they use this predefined vocabulary to index the articles, right, which are there. Okay, fine. So to find a mesh term, what you have to do is type your search here, type your search in the query box and click on go to type. So in this example, we will check for a mesh term called cancer. We will type cancer as a mesh term, and we will see whether cancer is a mesh term or not. Fine. So here from this result, we see that mesh term for cancer is neoplasms. So when you click that neoplasm, you will get linked term for more information, right? See, the record for mesh term contains a definition of the term that is the scope and definition of the term, associated subheadings, a list of entry terms, the tree view of mesh. So this is the definition of the term. These are the subheadings, that is the qualifiers, and these are the entry terms. They are not the mesh terms. Remember, the entry terms I told you they are cross references, and they are C also. Fine. C also, and C also terms. See, and the tree structure of the mesh terms. See, these many details you will get by typing a single keyword. So all subheadings associated with the mesh terms are displayed below the definition. This is the subheadings, right? And in this, there are two check boxes. The first restricts to major topic headings only. The second instruct PubMed not to explore. That means not to drop down. It should not include mesh terms find below the mesh tree. It should include only the broad heading, not the all the terms which follows below the mesh tree. So if you check this, if you uncheck it, it will not include. If you uncheck it, it will include. If you check it, it will not include. It will not explode. Okay, that is the function of that. So entry terms is listed along with C also reference. Entry term consists of C reference and C related and consider also, and C also is also there. Okay, fine. And this is the tree structure. So when you click this will include this only, not the explode box. It will not include all these things. Okay, it is each record has a tree view of mesh displaying the term and its positional in the mesh structure, where the position it is in the mesh structure. That is what we discussed about in permuted subject indexing, right? It will include everything irrespective of the position. So now, to search for records in Django, in the mesh term, try to type the query and click search, right? You will see we got around 17 results, and these are the number of mesh terms that containing the term Django, right? So we now click on the box on the term Django, and here is the Django as a mesh record and their associated subheadings and entry terms and other details along with other details. Now, to search PubMed, check the box next to the mesh term, and from the send to drop down menu, select click and search box under. So combine this search with the and operator, right? So what you do, you just select this box and click the search box with and. So what happens is Django will be a mesh term. From Django will be a mesh term. The term now entered in the search box. From here you can add another keywords in order to combine using and operator, right? So here are the Django results. So Django as a mesh term. Here are the Django as a mesh terms. Display around 4640 articles. Fine. So if you click on the abstract display, at the bottom of the abstract, you can view all the mesh terms. Okay, see, to search using subheading, select the appropriate subheading in the boxes. To use mesh term with subheadings in PubMed, you need to go to send to drop down menu and click on search boxes with and. Okay, fine. And you can combine more than one searches, right? Fine. And see, Django prevention and control. You are combining Django prevention and control as a mesh term. To use these terms in PubMed, you must click on search on PubMed, right? So here are the results for the particular search query. We got around 814 results. So you see Django prevention and control. If you click on the abstract display mesh terms, you can view all the terms, including the term which we have searched, right? Fine. So when we restrict to major topic headings only, we are just selecting articles that are primarily subject matter was Django, only to the major topic. So when we combine using subheadings like prevention or whatever it may be, then when we have prevention and control like this, when we are restricting it, it will cover only that aspect. So that is how you can make use of it. So now when you restrict it to major, it will become only a major broad area. Mesh terms is limited only to major topic headings. Again, only to broader context. So when you search like that, when you go, you will get results, and when you click an abstract, when you click an article, when you click the mesh terms, you will find all these things, all the major terms identify using asterisks. Fine, you can identify the major terms using asterisks. So this is the search history. The history compares the difference between searching dengue as a keyword, major term, and a mesh term. Fine. First one is keyword, second one is as a major term, next one is as a combined operator. So the mesh terms are assigned for geographical regions also and countries. In this example, we can look at the mesh term for Asia. So when you click on Asia, you can see the tree view by breaking down into different regions and country. So from the Asia, we will select Myanmar, right? Southeastern region. In this example, we can see that Burma and Myanmar are the entry terms for Myanmar, right? That are the related terms. Fine. So Myanmar is a mesh heading. Myanmar will be a mesh term, and the articles highlighted with Myanmar, their titles are 892 or 892. These are the result of searching Myanmar as a mesh term. In this example, we can see the definition of developing countries and entry terms that will map to the mesh term, right? So developing countries. So these are the entry terms for the mesh term, developing countries, right? Third world country, countries third world. So these are the related terms, cross-reference terms. So developing country as a mesh term. We got around 52,168 result. Fine. So this is all about medical subject headings. Kindly go through this references, and there is a good tutorial available in PubMed website also, and you can get a broader view about going through that tutorial also. Kindly go through this reference which is used to prepare this particular presentation. Thank you.